I know some people are not good at math or too lazy to actually do the math, so let me help you out. I will clarify some of the math along the way that I'm using so that if there's anyone that wants to reject these facts, they can research the formula themselves, but I'm not going to go into details of all the formulas. That'd take too long. Assuming the Earth is flat, then you can use simple trigonometry to calculate the height of an object if you know just two things. But why don't we do this visually? For example, we know that Polaris is directly above the North Pole, and we can measure our distance to the North Pole. And if we measure the angle from horizontal that we can see Polaris, we can calculate the height that Polaris is above the North Pole. An interesting fact is that the angle to Polaris will be equal to the latitude of your location. So that actually simplifies things quite a bit. I picked two pairs of cities that are on opposite sides of the Earth that were approximately the same latitude as another one. I used Anchorage, Alaska, which is right here, and Oslo, Norway, which is right here at about the same latitude. And then I also picked Cancun, Mexico, which is down here at the bottom, and Hanoi, Vietnam. Those pairs are all equal in latitude, roughly. And if you want to look on a globe type view, you can see here's Cancun. Follow the latitude across, there's Hanoi. Anchorage is there. Follow the latitude across, it's there. So you can see that they are pretty much similar. So I looked up the latitude of each of the places. Anchorage, Alaska is 61.2 degrees. Oslo, Norway is 59.91. So it's fairly close. Stockholm, Sweden. Oh, we're not using that one. Hanoi is 21.03 and Cancun is 21.16. And there's a simple formula that you can use to get your distance from the North Pole. We're going to use kilometers, so the distance kilometers is 90 minus your latitude times 111.32 kilometers. That'll give you the distance. And then if we want to graph a line, since we'll know the distance, that will give us our position on the ground away from the North Pole. And the equation of a line using an x-intercept, which will be d, the distance, is y equals tangent of the angle times x minus your distance. So with that information, let's plug that information into a graphing program and see what it shows. Here's Cancun. You can see it's drawn the line up over there to the angle. I've got negative tan times x minus 90 minus 21, which is the degrees, times 111.1, converting it to kilometers, gives us this nice line. And this right here at 0 would be where you would be seeing the North Star. So let's verify this to see if this formula works in here. So how far in kilometers is Cancun? 7,600 to 7,650 miles. So let's see, what does this actually cross at? You can see it's at 7,650. The math works. It matches. So now if we take Hanoi, it's on the other side of the Earth, just a little bit different. And if you look, it crosses at the same point, which is to be expected. If math on the flat Earth is going to work, they have to see the same thing at the same point. So the math works on a flat Earth. Imagine that. So let's do it again. We'll take Anchorage, Alaska. Anchorage, Alaska is here. Oslo, Norway is here. They match. So simple math works on a flat Earth. These people are both seeing the North Star at the same point. So this proves that simple math proves that Earth is flat. Or does it? Let's go back to the other two cities. Look at Cancun and Hanoi. They see the North Star here at about 3,000 kilometers. But Anchorage and Oslo, if you use simple math, it calculates at almost 6,000, almost twice as high. So how can Polaris be in two places at the same time? It can't. Simple math proves that the Earth cannot be flat. And if you do these exact same calculations on a globe, they all point to the same place. Imagine that. Simple math doesn't lie. Earth cannot be flat.